Work in calculus is very simple. Work is defined by the equation of the integral from one point to another, a to b, of fx times dx, where fx is the force applied in the object and dx is the distance, and the force is measured in newtons and the distance in meters. So the work is Newton meter, that it means that the work is in joules. Well, so let's have an example. The natural length of one spring is 1 meter. So, and we know that the work needed to stretch the same spring up to 2 meters, it's 50 newtons. 50 joules, sorry. How much work is going to be needed to stretch the spring up to 1.5 meters? We know that the work needed for the stretching one spring is the integral of k x times dx. So if we, from a to b, we replace a to b with 1 up to 2, well, only the distance from 1 to 2. So the work is going to be from 0 to 1, because it's the distance between those two, k x times dx. We know that the work is 50 joules, so we replace 50 joules here. And now we have to evaluate this integral to get k. 50 is equal to k x squared over 2 from 0 to 1. So 50 is equal to k x squared, evaluating x squared in 1, that is 1 squared over 2 minus 0. So we're turning here that 50 it's equal to k times 1/2. 100 it's equal to k. Here behind this, we already know the value of k, so we could move this one right here. And we don't need all of this anymore. So we have to replace in a new equation. So to get this, we have the work it's equal to the integral of 100, this is k, from 0 to 0.5, that is the distance from 1 to 1.5, of x times dx. So work is going to be 100 times x squared over 2, evaluated from 0 to 0.5. Then we evaluate these values in x. So work is going to be 100 times 0.5 squared over 2 minus 0. So work will be 100. 0.5 squared is 0.25 over 2. That means that work is going to be 25 over 2. The final result is 12.5 joules.